Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have a trigonometry. It's Unit 2, Lesson 3. The lesson is called Trigonometric Functions. In this lesson, inshallah, we are going to remember the main trigonometrical functions or ratios that we studied in the third prep, which was sine, cosine, and tan of the angle. In this lesson, inshallah, we are going to study a new functions called reciprocal of the main functions, and I'm going to explain later. And now we are going to study a very important topic called unit circle. Let's start the lesson. First, we need to remember the main trigonometrical ratios as we studied in the third prep. Okay, first, if we have a right angled triangle like this, okay, this is a right angle as we see, and this one is called the hypotenuse, and the two other sides called sides of a right angle. Okay, if we have an angle called theta, okay, here we have, according to theta, we have three sides in the triangle. The first side is called the hypotenuse, the second side is called the opposite to theta, which is opposite to it, and the next to theta called adjacent. If we change the position of theta here in this position, and theta means the acute angle, okay, then the position of the hypotenuse is stable, but we are going to change the position or switch the position of the adjacent and the opposite. For example, here is the opposite, which was the adjacent for the previous theta, and this is the adjacent of the theta, which was the opposite for the previous theta. Okay, now remember with me what is the sine, cosine, and tan. First, remember with me the sine of the angle. Sine, S-I-N-E, symbolized or abbreviation as S-I-N, okay, called sine theta. Sine theta is a ratio between the opposite side and the hypotenuse. Again, the sine of the angle is what? Is a ratio between the opposite and the hypotenuse of the triangle. Okay, now remember with me the cosine of the angle. The cosine of the angle symbolized as COS, which called cosine of the angle like this. Okay, this is cosine theta, which is the ratio between the adjacent and the hypotenuse. Again, the adjacent and the hypotenuse, which is cosine theta as we see here. Okay, finally we have tangent of the theta, or tan of theta, as we used to say it. Okay, tan of theta is the ratio between the opposite and the adjacent. Again, tan of theta is the ratio between the opposite and the adjacent. Okay, like this. Or we can say that tan equals sine over cosine. Again, tan equals sine over cosine. This is the main trigonometrical ratios, or the basic trigonometrical ratios. Okay, or in this lesson we called it functions. So sine, cosine, and tan are trigonometrical functions. Okay, let's study a very important topic called unit circle. Before explaining the unit circle, remember with me this symbol SOHCAHTOA. SOHCAHTOA, sine opposite hypotenuse, cosine adjacent hypotenuse, tan opposite adjacent. SOHCAHTOA. Okay, now let's study the unit circle. Okay, before explaining the unit circle, let me tell you what is the unit circle. The unit circle is a circle we are going to conclude most of the trigonometrical rules that you are going to study in the next lessons and the next term and in the next years, inshallah, depend on this unit circle. Okay, now we have a circle. This circle, as I said, it's called unit circle. Unit means, okay, its radius equal 1 unit. Okay, now we have the two coordinate axes, x and y axis, as we see. As I said, it's a unit circle, so its radius equal 1. So from 0 to 1, here 1, and here 1, and here from 0 to negative 1, and here from 0 to negative 1 also, like this. Okay, 1, 1, negative 1, negative 1. Its radius equal 1. We have a point belong to the unit circle like this. This point called x and y. Okay, the distance between this point and the origin, okay, like this, equals 1 unit. Okay, this line segment formed an angle with the positive direction of x-axis called theta, like this. Okay, why do I choose the positive direction of x-axis? Because this is the standard position as we studied in the last lesson. Okay, now I'm going to draw a right angle triangle, okay, to identify sine, cosine, and tan of this angle, because as we studied, the sine, cosine, and tan depend on a right angled triangle. So like this, I'm going to draw a right angle triangle like this. Now here, this point called x and y. Okay, this base is the distance from origin to this line belong to x-axis, then this one equal x coordinate, and this line is y coordinate. So like this line equal x and this line equal y. Again, the base of the triangle equal x and the height of the triangle equal y. And this is for all unit circles we are going to study, inshallah, and the hypotenuse forever equal 1 for the unit circle. Okay, now let's conclude the main trigonometrical ratios or main trigonometrical functions, sine, cosine, and tan. Okay, first, this is the basic trigonometric functions of the angle theta. Okay, the basic are sine, cosine, and tan. Okay, number 1, the sine of the theta. The sine of the theta, which is the opposite over the hypotenuse, again the opposite over the hypotenuse, which is y over 1 like this, and y over 1 equal y. Okay, cosine of theta. Cosine, which is adjacent over the hypotenuse, okay, it x over 1, which is equal x. Finally, tan of theta, which is the ratio between opposite and adjacent. Again, ratio between opposite and adjacent, it y over x. Okay, now sine of theta equal y, cosine theta equal x, tan theta equal y over x, and this is for the unit circle. This is a very important rules. Okay, here x is the cosine and y is the sine for any point belong to the unit circle. Remember with me the Pythagorean theorem. The Pythagorean theorem is side power of 2 plus, for any right angle triangle, side power 2 plus side power 2 equals hypotenuse power 2, like this. X power of 2 plus y power of 2 equals 1 power of 2, which is 1. This is the rule related to the unit circle. Now, let's study a new topic called reciprocal of trigonometrical functions. New trigonometrical functions. We studied before sine, cosine, and tan. We have 3 new functions. Okay, let's study them by using the same unit circle. Okay, the reciprocal of the basic trigonometric functions of the angle. Reciprocal means multiplicative inverse. Again, reciprocal means multiplicative inverse. Okay, the first reciprocal was us called secant of theta. Again, secant of theta. And we are going to abbreviate this one as SEC to be sec theta. Again, sec theta is the abbreviation of secant of theta. Sec theta is the reciprocal of the cosine. So sec theta equals 1 over cosine. And 1 over cosine, remember with me, equals 1 over x. So sec theta equal 1 over x. Okay. Number 2, we have cosecant theta. Again, cosecant theta. Cosecant theta abbreviate as CSC like this. This is cosec theta. Again, cosec theta. Cosec theta is the multiplicative inverse of the reciprocal of sine. It will be equal 1 over sine theta. It will be 1 over y. Finally, cotangent theta. Again, cotangent theta. Cotangent theta abbreviate as COT, cotan theta. Read as cotan theta. Cotan theta is the multiplicative or the reciprocal of tan. It will be equal 1 over tan. And 1 over tan means cosine over sine, because tan equals sine over cosine. It equals x over y. Finally, we have sec equal 1 over cosine, cosec equal 1 over sine, cotan equal 1 over tan, or cosine over sine. And this one called the reciprocal of the basic trigonometrical functions of the angle. Now let's solve the first example with us. Example 1. Find all trigonometric functions of angle whose measure theta drawn in the standard position. Its terminal side intersect the unit circle at the point number 1. 2 over 3 root 5 over 3. Okay. Now when he say all trigonometrical ratios, then he means sine, cosine, tan, and sec, cosec, and cotan. Okay, now start with, this is x, this is the cosine, this is y, this is the sine, sorry. Okay, x is the cosine, y is the sine. So sine theta equals y, which is equal root 3 root 5 over 3, and its opposite is cosec theta equal, make this one upside down, it will be 3 over root 5, and you are going to make it in the simplest form. It's up to you. Okay, number 2, the cosine of theta, which is x. X here is 2 over 3. So the opposite to cosine theta is sec theta, which is equal, make theta upside down, it will be 3 over 2. Finally, tan theta equal y over x, again equals y over x, or sine over cosine. It will be root 5 over 3 divided by 2 over 3 equals root 5 over 2. Of course, by using calculator. Okay, now we have tan equal root 5 over 2, so cotan theta equal, make the 10 upside down, it will be 2 over root 5. And I will leave it to you, you make it in the simplest form. Okay. Number 2, 0 and 1. X equal 0, y equals negative 1. The cosine is 0, the sine is negative 1. So cosine theta equals 0. Now sec theta equals, this is 0, so it will be 1 over 0, which is undefined. Okay, now sine theta. Sine theta, which is y, which is negative 1. Cosec theta equals 1 over sine, which 1 over negative 1, which is negative 1. Finally, tan theta. Tan theta equals y over x. Again, y over x. Negative 1 over 0 equals, is undefined. And cotan theta, okay, equal x over y. Again, x over y, 0 over negative 1 equals 0. And this is all trigonometric functions. If he said basic trigonometrical functions, say, so we will write sine, cosine, and tan only. But if he say all trigonometric functions, so I'm going to write all of them: sine, cosine, tan, sec, cosec, and cotan. Okay. Now let's study the equivalent angles. Okay, the equivalent angles have the same trigonometric functions. How come? Before we studied the equivalent angles, for example, if we have angle like 50, so when we add 360 to 50, it will be 410. So 50 and 410 called equivalent angle. When we add 360 or subtract 360, we get an equivalent angles to the main angle. Okay. Now, for example, if we have cosine 420. Okay, 420, I may change this one as to be 360 plus 60. By subtract 360 minus 420 minus 360, we get 60. Okay, so I am going to cross 360 like this to be cosine 60. So cosine 420 is the same as cosine 60. Okay. Another example, if we have sec 840. 840 included 120 plus 2 times 360. You can do it by calculator. 820 minus 360 and the minus 360 again to get 120. So I'm going to cross 2 times 360. So it will be finally 120. This is the main angle. So sec 840 is the same as sec 120. Okay, because they are equivalent angles. Okay, and I'm going to explain how can we do it in the questions by doing minus 360 and the minus 360. Okay, now let's study a very important topic called sign of trigonometrical functions. Type sign of the trigonometrical functions by according to the 4 quads: the first, the second, the third, and the fourth quad. Okay, how can we know the sign without evaluate the sign of the function without evaluate this function? Okay, now remember with me the unit circle. Okay, the unit circle, as we studied before, okay, this is the circle that we are going to conclude most of the rules of the trigonometry. Okay, now if we have a point here, this point belongs to the first quadrant, and this is the second and third, fourth. Okay, back to the first quadrant. This point, x and y, belongs to the first quadrant. Okay, this point makes an angle in the standard position called theta. Okay, this point has two coordinates, x and y. So x here is positive and y here is positive. Again, x is positive and y here is positive. So the two coordinates x and y, positive, positive. Okay, here this is the cosine and this is the sine. The cosine is positive and the sine is positive. So the sine is positive, the cosine is positive, the tan is positive over positive, again positive over positive equal positive. So sine, cosine and tan, all of them are positive in the first quadrant. Okay, in the second quadrant, if we have a point here, this point has two coordinates, x and y. X here is negative, here x is negative, this is the positive direction of x-axis and this is the negative direction of x-axis. Here the positive direction of y-axis, here the negative direction of y-axis. Okay, here x is negative and y is positive, like this. Okay, this is theta in the standard position, which belongs to the second quad, comes from the positive direction of x-axis to here. Okay, this one has two signs, negative and positive, x and y. X is negative, y is positive. Okay, so I can conclude the signs like this. Sine theta here is positive, cosine theta here is negative, tan theta is positive over negative, again positive over negative is negative. So the sine is positive, cosine and tan are negative. So here not all of them positive like the first quadrant, no, the sine only is positive and the cosine and the tan are negative. Okay, in the third quad, I'm going to draw a point and I'm going to draw an angle from the standard position like this. You see the angle here comes from the positive direction of x-axis. Okay, and its terminal side belongs to the third quadrant. Okay, now this point has two coordinates. This coordinate is negative and this coordinate is also negative. It will be negative, negative. Okay, here the sine is negative and the cosine is negative also. The tan here is negative divided negative is positive. So here the tan is positive and the rest are negatives. Okay, by looking to the fourth quadrant, if we have a point like this and I need to draw an angle, so it comes from the positive direction of x-axis to be this angle from the standard position. Okay, this angle belongs to the fourth quadrant. Here the fourth quadrant, x is positive and y is negative. Again, x is positive and y is negative, like this, positive, negative. Okay, so the sine is negative and the cosine is positive. The tan is negative divided positive equals negative. So finally we can conclude this rule. Here sine, cosine and tan, all of them are positive. And here sine, cosine and tan, the sine only is positive. Here sine, cosine and tan, the tan only is positive. Here sine, cosine and tan, positive here, cosine here is positive. So all are positive, sine is positive, tan is positive, cosine is positive. This one called asterisk rule, by taking the first letter from all and from sine and from tan and from cosine to be like this, it will be asterisk rule. Asterisk rule means all sine, tan, cosine. This is a very important rule. Okay, now remember with me, in this quadrant, sine, cosine, and tan and their opposites, sec, cosec, sec, and cotan are positive. Here, sine is positive and cosec is positive. Here also, cosec is positive. Here, tan is positive and cotan. Here, cosine is positive and sec. So, here all of them positive. Here, sine and cosec, tan and cotan, cosine and sec. Okay, now let's study the next question. Now, this is a coordinate axis, x-axis and y-axis. If we have an angle belong to the first quadrant like this called theta, and to identify sine, cosine, and tan for this angle, I'm going to draw the right angle triangle like this. Okay, here this line equal 3 units, and this line equal, as you see, 4 units. Okay, the hypotenuse, I can evaluate the hypotenuse like this, square root 3 to the power of 2 plus 4 to the power of 2 equals 5 units. So the hypotenuse equals 5 units. Okay, now I can conclude the sine equal opposite over hypotenuse 4 over 5. The cosine equal adjacent over hypotenuse 3 over 5. The tan equal opposite over adjacent 4 over 3. Okay, another triangle. Here theta belongs to the second quadrant. I'm going to draw the right angle triangle like this. Here the base equal -3. Remember, -3. Here this line equal +4. And the hypotenuse from Pythagorean theorem equals 5 units. So now to conclude the sine of the angle, it equals 4 over 5. And the cosine of the angle equals -3 over 5. And the tan of the angle equal 4 over -3. Again, tan theta here equal the opposite equal 4 and the adjacent equal -3. It will be 4 over -3. So again, sine theta equal opposite over hypotenuse 4 over 5. Cosine theta adjacent over hypotenuse -3 over 5. Tan theta opposite over adjacent equal 4 over -3. Okay, next, if we have theta belong to the third quadrant, so by drawing the right angle triangle like this, here we have the base equal -3, the height equal +4, and the hypotenuse equal 5. Okay, now sine theta. Sine theta equal opposite over adjacent -4 over 5. Again, -4 over 5, opposite over hypotenuse. Okay, cosine theta equal adjacent over hypotenuse. Again, adjacent over hypotenuse, -3 over 5. Tan theta equal opposite over adjacent. -4 divided -3 equals +4 over 3 like this. Okay, in the fourth quad, theta belongs here to the fourth quad by drawing the right angle triangle as we see. Here the base equal +3, the height equal -4. Why -4? Because it is in the negative direction of y-axis. Okay, it's parallel to -4. the hypotenuse equal 5 by using Pythagorean theorem. Okay, now sine theta equal opposite over hypotenuse, again opposite over hypotenuse, negative 4 over 5. Cosine theta adjacent over hypotenuse, positive 3 over 5. Tan theta opposite over adjacent, negative 4 over positive 3 equal negative 4 over 3. So by looking to the four quads, here all of them are positive, here the sine only positive, here the tan only positive, here the cosine only positive. Okay, let's study the next question. In this example, determine the sign of the following trigonometric functions. Okay. Number 1, cosine 350. 350 belongs to the fourth quad. Remember with me the asterisk rule. All positive, sine positive, tan positive, cosine positive. Okay, this is the asterisk rule. So cosine in the fourth quad is positive. Here sine 5 pi over 4, which is equal sine, remember with me, pi equal 180, so it will be 5 times 180 over 4 equals 225 degrees. Okay, sine here 225 belongs to the third quad, so it is in the third quad. Tan in the third quad is positive and the rest are negative, so it will be negative. Cosec 1180. So I'm going to subtract 360. Okay, minus 3 times 360, or by using calculator like this, 1200 minus 360 equal minus 360 again equal minus 360 again equal. So it will be 120. This equal cosec 120 degrees. This is in the second quadrant. The second quadrant, cosec is 1 over sine. So in the second quadrant, sine is positive, so cosec also is positive. Number 4, cosine negative 165 plus 360. So it will be cosine 195. 195 belongs to third quad, and cosine in the third quad is negative. So it is negative sine. Cotan negative 3 pi over 4 equal cotan negative 3 times 180 over 4 equal negative 135 plus 360 equal cotan 225. 225 belongs to the third quadrant, and the third quadrant tan is positive, so cotan also is positive. Number 6, sec negative 25 pi over 6. Negative 25 times 180 over 6 equals negative 750. Plus 360 plus 360 plus 360 equal sec 330. Again, plus 360 plus 360 plus 363 times. Okay, it will be sec 330. 330, this is in fourth quadrant. Sec is the opposite of cosine, so it will be positive in the fourth quadrant. Next question. Example 3. If theta is the measure of the directed angle in the standard position, and B is the intersection point of its terminal side with the unit circle, then find all the trigonometric functions of theta in each of the following cases. This is exactly as we studied in the example 1, but here there is a missing number. Okay, why here is missing? To get y, remember with me, x power of 2 plus y power of 2 equals 1. This rule related forever for the unit circle. Okay, so to get y equals square root 1 power of 2 minus 0.6 all power of 2, it is equal to 4 over 5. Y equals 4 over 5 and the x equal 0.6 or 3 over 5. So cosine theta, sine theta first, which is y, equals 4 over 5. Don't forget here, y equals negative or positive 4 over 5. Again, y equal negative or positive 4 over 5. But y is greater than 0, so I'm going to take the positive value and I'm going to refuse the negative value. So for y equals 4 over 5. This is the sine, and the cosec theta equals 5 over 4, the reciprocal of sine, and cosine theta equals 0.6 or 3 over 5. So sec theta equals the reciprocal, which is 5 over 3, and tan theta equals y or equals sine over cosine. 4 over 5 divided 3 over 5 equals 4 over 3. So cotan theta equals the reciprocal, which is 3 over 4. Okay, next, b equals negative root 3 over 2 and y, where theta belongs to the second quadrant from 90 to pi. The second quadrant, any point belong to the second quadrant is negative and positive. Remember, any point belong to the second quadrant is negative and positive. So y must be positive. So y equal what? Here, negative root 3 over 2 all power of 2 plus y power of 2 equals 1. I'm going to send this one to the other side. So y equal, and take the square root, y equals square root 1 minus this number to the power of 2 equals 3 over 4. Don't forget negative or positive. Okay, root 1 minus 3 over 4 equal negative 3 over 4. Negative root 3 over 2. So y equal negative or positive 1 minus 3 over 4 equal quarter. Square root quarter equal 1 over 2. So it will be 1 over 2. But negative is refused. So y, therefore y equals 1 over 2 and the x equal negative 3 over 2. Now sine theta equals 1 over 2 and cosec theta equals 2 over 1, which is 2. Cosine theta equals negative root 3 over 2 and sec theta equal the reciprocal, which is negative 2 over root 3. Tan theta equals sine over cosine, half divided negative root 3 over 2, which is equal negative 1 over root 3. And cotan theta equals the reciprocal of tan equal negative root 3 over 1, which is negative root 3. Next. Now b equal negative x and negative x. So negative x power of 2 plus negative x all power of 2 also equals 1. So x power of 2 plus x power of 2 equal 2x power of 2 equal 1. By send 2 to the other side and take the square root, so x equals negative or positive square root 1 over 2. So x, here x greater than 0, then the negative if refused is refused, therefore x equal positive 1 over square root 2. Okay, this is x. Now the cosine equal negative 1 over root 2 and the sine equal negative 1 over root 2. So sine theta, this is sine theta, which is negative x, equal negative 1 over root 2. You can simplify this one by using calculator. Okay, now cosec theta equal negative root 2 over 1, which is negative root 2. Okay, cosine theta equals negative x, which is negative 1 over root 2. And sec theta equal reciprocal of this one equal negative root 2. Tan theta equal sine over cosine, negative 1 over root 2 over negative 1 over root 2 equal 1. Cotan theta equal the reciprocal of 1, which is also 1. Okay, number 4. b equal 3 over 2a and negative 2a, where theta belongs to 3 pi over 2 and 2 pi. This is the fourth quadrant. The fourth quadrant is positive and negative. So the first is positive and the second is positive. So a here must be positive. Okay, because positive gives positive and negative positive gives negative. Okay, say a must be greater than 1, greater than 0 or positive. Okay, here 3 over 2a all power of 2 plus negative 2a all power of 2 equals 1, and by distribute the power of 2, so 9 over 4a power of 2 plus 4a power of 2 equals 1. So by adding 9 over 4 plus 4 equal 25 over 4 a power of 2 equals 1. Send 25 over 4 there as a divide. So a power of 2 equals 1 divided 24 over 4 equal 4 over 25. Therefore, a equals negative or positive square root 4 over 25. So a equal negative or positive 2 over 5. As I said, a must be positive. Therefore, a equal 2 over 5 and the negative is refused. So sine theta equal 3 over 2a equals 3 over 2 times 2 over 5 equals 3 over 5. And I will leave the cosec for you. Cosec equal 5 over 3 and cosine theta equal negative 2a, negative 2 times 2 over 5 equal negative 4 over 5 and the sec equal negative 5 over 4. Finally, tan theta equals sine over cosine. Again, sine over cosine equal 3 over 5 divided negative 4 over 5 equal negative 3 over 4. And I will leave the cotan for you. The cotan equal negative 4 over 3. Now, let's study the trigonometric functions of some special angles. And this is a very important concept. You can identify all what I'm going to teach you by using calculator, but sometimes the calculator gives you math error, so you have to understand how can we conclude the sine, cosine, tan for the special angles like this. Okay, I will start with the unit circle as we used to study. Okay, here this point is 1, so it is 1, 0. And this one is also 1, belongs to y-axis, so it will be 0, 1. And this one is negative 1, 0. And here 0, 0, negative 1. Okay, now I can here as we studied in the last lesson, this angle equals 0 and this angle equals 90 degrees and this angle equals 180 and this angle 270 and 0 of course looks like 360. And by changing them in the radian measurement, 0, pi over 2, pi, 3 pi over 2 and 2 pi. Okay, now those are the angles in degree: 0, 90, 180, 270, 360. Okay, now I need to conclude sine, cosine, tan for 0, 90, 180, 270 and so on. Sine, cosine and tan. Start with 0. Now 0 intersect x-axis at 0 and 1 and 0. Okay, say so its cosine equal 0 and its sine equal its cosine equal 1 and its sine equal 0. Sine equal 0, cosine equal 1. To find the tan, sine over cosine, 0 over 1 equals 0. Now 90 degrees intersect the unit circle at 0, 1. So the sine equal 1 and the cosine equal 0. Tan equal 1 over 0. 1 over 0 equal undefined. Okay, so by using the calculator, it gives you, if you write sine 90, it will give you a math error. Okay, now 180 degrees. 180 degrees intersect the unit circle at -1 and 0. So the sine equals 0 and the cosine equal -1. Tan equals 0 over -1 equals 0. 270. Intersect the unit circle at 0, -1. Sine equals -1, cosine equals 0. Tan equal -1 over 0 is undefined. 360. Oh, 360 is the same as 0. Its sine is 0 and cosine equal 1 and tan equal 0. Now I'm going to conclude 30, 60 and 45, but you already have studied in the third prep. Okay, now if we have an angle of measure 30 like this angle, by draw a right angle triangle, okay, its hypotenuse equal to 1 and the opposite, as we studied before, equal half. The hypotenuse equals half. This line I can find its measure by using the Pythagorean. I'm going to explain. This line equals square root 1 power of 2 minus half power of 2, like this. Square root 1 power of 2 minus half power of 2 equals root 3 over 2. So the base equal root 3 over 2, like this. Now I can conclude sine, cosine and tan of 30 from this triangle. Okay, 30 degrees, its sine equal opposite over hypotenuse, half over 1 equal half. Its cosine adjacent over hypotenuse, root 3 over 2 divided 1 equal root 3 over 2. Its tan equal opposite over adjacent, half divided root 3 over 2 equal 1 over root 3. But the calculator will give you root 3 over 3. Okay, it's okay, you can write any of them. Okay, now the 60 degrees. By looking to this triangle, 90, 30 and third angle equal 60 degrees. Okay, the adjacent to 60 equal half, the opposite equal root 3 over 2 and the hypotenuse equal 1. So sine 60 equal root 3 over 2 divided 1 equal root 3 over 2. Cosine 60 half divided 1 equal half. Tan 60 opposite over adjacent, root 3 over 2 divided half equals root 3. Okay, by the same way I can conclude 45 angle. Okay, here if this angle equal 45, so this angle also equal 45 degrees. By using the Pythagoras theorem, this one equal 1 over root 2 and this one equal 1 over root 2. Okay, because this is an isosceles triangle. Okay, what will happen? Here cosine sine 45 opposite over hypotenuse equal 1 over root 2. Cosine equal also 1 over root 2. Tan equal 1 over root 2 divided 1 over root 2 equals 1. Now this is the main trigonometrical functions for 0, 90, 180, 270, 30, 60 and 45. Now let's study the same angles but conclude sec, cosec and cotan. Now I'm going to use the same table and I'm going to complete another table. Cosec, sec and cotan. Remember with me, cosec is 1 over sine, sec is 1 over cosine, tan is 1 over tan. Cotan, sorry, 1 over tan. Okay. Now cosec 0, it will be 1 over 0, which is undefined. Sec 0, which is 1 over 1 equals 1. Cotan 1 over 0, which is undefined. Okay. Now 90 degrees, cosec 90 equals 1 over 1 equals 1 and 1 over 0 equal undefined. And here cosine over sine 0 over 1 equals 0. Okay, 180. 1 over 0 is undefined. 1 over negative 1, negative 1. 1 over 0 is undefined. Now 270, 1 over negative 1, negative 1. 1 over 0 undefined. And cosine over sine 0 over negative 1 equals 0. Now 30, 1 over half or upside down half equal 2. Upside down 2 root 3 over 2 equal 2 over root 3. Upside down 1 over root 3 equal root 3 over 1 or root 3. Now 60. Upside down root 3 over 2 equal 2 over root 3. Upside down 1 over 2 equal 2. Upside down root 3 equal 1 over root 3. And here, upside down 1 over root 2 equal root 2. Upside down 1 over root 2, root 2. 1 over 1 equal 1. Okay, now let's solve the next question. Here, find the value of the following. You can use calculator or you can use a table. It's up to you. Here, sine 0 equal to 0 plus sine 90 equals 1 plus sine 180 equals 0 plus sine 270 equals negative 1. Finally, it's equal to 0. Number 2, sine 180 equals 0 times cosine 45 equals 1 over root 2 minus cosine 180 equals negative 1 times sine 45 1 over root 2. It's equals 1 over root 2, but the calculator will give you root 2 over 2. It's correct. Pi over 2, 90. Cosine 90 equals 0 times cosine 0, 1 plus 3 pi over 2, which is 270. Sine 270 equals negative 1 times pi over 2 equals 90. Sine 90 equals 1. It's equal to negative 1. Now number 4, 3 times sine 31 over 2 times sine square 60. Sine 60 equal root 3 over 2 all power of 2 minus cosine 0 equals 1 times sec 60. Okay, now let me teach you how can you calculate sec 60. Sec is 1 over cosine, so you can do it 1 over cosine 60. This is how to evaluate sec in the calculator. 1 over cosine 60 equal 2. So it will be 2 plus sine 270 equals negative 1 and cosine square 45 equals 1 over root 2 times all power of 2. Finally, this one equals negative 11 over 8. Number 5, sec pi over 6. Pi over 6, which is 60. So you are going to make on the calculator 1 over cosine 30. 1 over cosine 30 equal 2 over root 3 times 10 pi over 3, which is 60. 10 60 equals root 3 minus cotan. Cotan, you are going in the calculator to write 1 over 10 pi over 3 means 60. 1 over 10 60 equals 1 over root 3. times cosine pi over 6 equal 30. Cosine 30 equal root 3 over 2. So finally this one equal 3 over 2. Example 5. Prove that the following equalities. Okay, now I'm going to start with the left hand side. It equals 2 times sine squared 90. Sine 90 equals 1, so it will be 1 power of 2. It will be 2. Okay, the right hand side equals negative 2 times cosine 180 equals negative 1. Negative 2 times negative 1 equal 2. Therefore, the left hand side equal to the right hand side. Pi over 2, which is 90, the left hand side equals cosine 90 equals 0, and the right hand side cosine square pi over 4 equal 45. So cosine 45 1 over square root 2 all power of 2 minus pi over 4 also 45. Sine 45 equal 1 over root 2 all power of 2. It equals to 0. Therefore, the left hand side equal to the right hand side. Okay. Example 3, number 3, also prove that. Start with the left hand side. Equals sine 60 root 3 over 2 times cosine 30 root 3 over 2 minus cosine 60 1 over 2 times sine 30 1 over 2. It equals to 1 over 2. The right hand side equals sine square pi over 4 equal 45. So it will be 1 over root 2 all power of 2 equals 1 over 2. Therefore, the left hand side equal to the right hand side. Number 4, sec 30 you will evaluate it by 1 over cosine 30. It will be 2 over root 3 times tan 60 equals root 3 plus sec square 60. Sec 60 equal 1 over cosec 60, 1 over sine 60 equal 2 over root 3 all power of 2 minus tan 45 equals 1 power of 2. This one equal 7 over 3. Therefore, the left hand side equal to the right hand side. Example 6. Find the value of x if x times sine square pi over 4 cosine pi equal tan square pi over 3 sine pi over 2. Okay. Here x times Sine square pi over 4, 45 means 45. Sine 45 equal 1 over root 2. All power of 2 times cosine 180 equals negative 1 equal the right side tan pi over 3 equals 60. Tan 60 equal root 3 power of 2 times 3 pi over 2 equals 270. Sine 270 equals negative 1. Okay. Now x times this one equals negative half. Negative half equal this one equals negative 3. By send this one there, so x equal negative 3 divided negative half equal positive 6. Example 7. If x equal from 0 to 90, that means x belongs to the first quadrant. Again, x belongs to the first quadrant. Okay. Then find the value of x which satisfies the following equation. Cosine x equal, as we see. Okay. Cosine x equal. Here, sine 60 equal root 3 over 2 over sine 90 equals 1 minus sine 0 equal to 0 over sine 45 equals 1 over root 2. This one equal root 3 over 2. X here is positive. Okay, x is positive in the first quadrant and in the fourth quadrant by using the asterisk rule. But he gives me this given x belongs to the first quadrant, so I will find the answer using the first quadrant only. Okay, how can I get this one? I will make shift cosine root 3 over 2. Shift cosine x equal shift cosine root 3 over 2. Or if you keep this one, you know that cosine 30 equal root 3 over 2. Okay, then x equal 30 degrees. Example 8. Find all trigonometric ratios for angle AOB whose measure is theta in each of the following cases. Number 1, 0 and pi over 2 and pi, tan theta equal negative 3 over 4. Now I can solve this one by two different ways. He didn't give me unit circle, so I can solve this one by using the unit circle or by using the draw in general, right angle triangle in general. Okay, I will teach you how can I use the right angle triangle in general. It will be like this. You are going to draw the two quadrants, x-axis and y-axis. Okay, here pi over 2 and pi, this is the second quadrant. In the second quadrant, I'm going to draw a right angle triangle like this. Okay, now tan theta, this is theta. Okay, tan theta, opposite over adjacent, opposite over adjacent. Opposite equal 3, adjacent equal negative 4. Why negative 4? Because this is the negative direction of x-axis, so it must be negative in this one. Okay, by using the Pythagoras, okay, the hypotenuse equal square root 3 power of 2 plus negative 4 power of 2 equals 5. See, so the hypotenuse equals 5. Now I can conclude all the trigonometrical ratios for this angle by using this triangle. Okay, now sine theta. Sine theta opposite over hypotenuse equals 3 over 5. Cosec theta equal 5 over 3. Cosine theta adjacent over hypotenuse negative 4, and sec theta equal 5 over 4, negative 5 over 4. Finally, tan theta equal negative 3 over 4, and cotan theta equal negative 4 over 3. Okay. Now theta belong to pi and 3 over 2. This is the third quadrant. Again, pi and 3 pi over 2. This is the third quadrant. I can solve this one by two different ways. By using the unit circle or by using draw right angle triangle in the quad. Okay. Now I'm going to draw in the third quadrant like this. Remember that the angle forever with the positive, the angle forever with x-axis. So here is theta. Now cosec. Cosec is the hypotenuse over the opposite. Again, the hypotenuse over the opposite. So the hypotenuse is 25 and the opposite is 7. But this is the negative direction of y-axis, so it will be negative 7. Now I need to conclude the x-coordinate by using the Pythagoras theorem like this. I'm going to use the calculator direct. Square root hypotenuse power of 2 minus side power of 2. 25 power of 2 minus open bracket negative 7 close bracket power of 2 equals 24. So this is 24, but because this is the negative direction of x-axis, so this one will be negative 24. Okay, now I can conclude all the functions. Here, sine theta equal opposite over hypotenuse equal negative 7 over 25. Cosec is exist, and cosine theta equal adjacent over hypotenuse equals negative 24 over 25, and sec theta equal the multiplicative inverse equal negative 25 over 24. Okay, tan theta equal opposite over adjacent, again opposite over adjacent, negative 7 divided negative 24 equal positive 7 over 24, and cotan theta equal multiplicative inverse of the tan equal 24 over 7. Note here, all of them are negative except tan and cotan. Now let's study the summary of the lesson. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.